to write a formula and how to write a name if formula is given about ionic compounds. Now we are going to discuss writing formula for molecular compounds. Okay, for molecular compounds, you have to know these terms. We use mono for 1, di for 2, and tri for 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Okay, now how to write a name for any molecular compound? It's very simple. First, we have to follow the same rule. How many elements here? 1 and 2. So it means it ends with IDE. Okay. Now you have to write number of atoms. How many nitrogen atoms here? 2. So you will write dinitrogen. Because 2 nitrogen, dinitrogen. How many oxygen? 5. Dinitrogen pentoxide. Okay. Now next is here. How many nitrogen? 1. And oxygen 1. So the name should be mononitrogen monoxide. But if first element is 1, there is first element has 1 atom, so we will not write mono with first. Now it should be mononitrogen monoxide, but nitrogen is first, so we will not write mono with nitrogen. So only nitrogen monoxide. In next example, how many nitrogen here? 2. So dinitrogen monoxide. Now again here, nitrogen dioxide, silicon dioxide. Now come to this side. It is phosphorus trichloride, phosphorus pentachloride, sulfur dioxide, sulfur trioxide, carbon dioxide. Now, any question, boys? Any question? So this is how to write a name for molecular compound. Here is an example. So what should we write its name? Si?
Silicon.
Very good. Silicon. How many chlorine? 4. It is tetrachloride. Okay. How many phosphorus?
For phosphorus dioxide.
Very good. Tetra phosphorus.
Octa.
Phosphorus.
Oxide.
Yes. Decoxide. Very good.
Oxide.
Decoxide. Very good. Excellent.
Why we add tetra?
Because the 4 phosphorus. 4 atoms of phosphorus. So tetra phosphorus decaoxide. Okay, another example. SCl3. Sulfur. How many chlorine? 3. So trichloride. Simple. Okay. Here, carbon disulfide. So carbon C disulfide.
S2,
Sulfide
S2,
S2. Very good. S2. CS2. Carbon disulfide. Okay. Disilicon.
S2,
Si2. Hexabromide.
BR6.
Br6. Good. Excellent. Okay. Okay, students. Now, molecular compounds, there are different examples written here. So, if you will find any problem, you can ask me. Okay. Now here is this table, very, very important, boys. You must save left side all. You must save this, this, and this. 1, 2, and 3. You must save all this table. Every time 2 questions are present from this table. In all quizzes, all exams, in all assignments. And from this side, left side all, and right side only these 3 you have to save. Okay, now question is how to save. Okay, friends, here it's very important, very important. Here you see fluorine, chlorine, bromine, iodine. What are these? These are halogens. These are halogens. When you add H with halogens, it becomes acid. Okay. Now these acids start with hydroic acid. Hydroic acid. Now what is in between here? If it is F fluorine, it becomes fluor hydrofluoric acid. It is chlorine hydrochloric acid. It is bromine hydrobromic acid. It is iodine hydroiodic acid. Any problem? Okay, it is cyanide. Cyanide. So it becomes hydrocyanic acid. Cyanic acid. Hydrocyanic acid. Yes, boys. Any question? So very simple. Hydro, name of the element, IC acid. Hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrocyanic acid. Okay. Now, next. Here, when you see oxygen, don't write hydro. Now here, oxygen present here. Look, here I told you to save this one. Oxygen present here. Here, oxygen present. Here, oxygen present. So don't write hydro. Don't start with hydro. So what will you do? You will end with IC acid. IC acid. How? When you read that table, I told you before, it is acetate. Acetate. It becomes acetic acid. Acetic acid. It is nitrate. It becomes nitric acid. It is sulfate. It becomes sulfuric acid. It is phosphate. It becomes phosphoric acid. So this is a method how to save these names. If you see oxygen, don't start with hydro. If no oxygen, then start with hydro. Okay, friends, next. Come to this table. What is this table, boys? From this table, you have to save only 2. Others you will easily understand. How? I will show you here. You have to save HClO3, HClO2. All students are with me?
Yes.
Yes.
Good.
Yes, sir.
Mashallah. Okay, good. If 3 oxygen, then you will end with IC acid. It is chloric acid. Chloric acid. Why chlor? Cl. Chloric acid. Now, if 2, it is chlorous acid. So, it is ic acid. It is us acid. Okay. Okay, friends. When you add 1 oxygen here, it becomes HClO4. Now you are adding 1 oxygen. Here just add per same name, chloric acid. Per mean more. So here you are adding one more oxygen, so it becomes perchloric acid. Perchloric acid. Okay, next. Come to this one. When you remove one oxygen, here it becomes HClO. Now it is chlorous. It becomes hypochlorous. Hypochlorous acid. Now hypo mean low. Low. It means here one oxygen low in this oxygen. So it becomes just add hypo with this. Hypochlorous acid. So you have to remember two names. Chloric acid, chlorous acid. When you remove one oxygen, it becomes hypo. This acid, hypochlorous acid. And when you add one more oxygen, it becomes per this acid. It means perchloric acid. Okay. Now, this chlor, it is due to this chlorine. Okay. If I write HBrO4, what should be its name? Perbromic acid. Same thing. Perbromic acid. If I write HBrO3,
Bromic acid.
bromic acid. Good. If I write HBrO2,
Bromic acid.
excellent. Bromous acid.
bromous acid.
HBrO.
High bromic acid.
Excellent. Excellent. Hypobromous acid. Very good. If I write HiO4,
Perchlorate
Iodine.
acid.
Where
Iodine. Very good. Per iodic acid. If I write HiO3,
iodic acid.
iodic acid.
Hydroxylic
Good.
acid.
Excellent. HiO2. Iodous acid. If I write HiO, simple.
Iodine.
Iodic acid.
Hypoiodous acid. Very good, boys. It means you can easily write names of these elements. Clear this one?
Clear.
Okay, good. Okay. Okay, students, now come to the second part of this table. Now these are ions. When you remove hydrogen from these acids, it becomes ion. It becomes ClO4 minus, ClO3 minus, ClO2 minus, ClO. Okay. Now how to write their names? It's very simple. If you remember these, perchloric acid, chloric acid, chlorous acid, hypochlorous acid, it is very simple. Change ICS to ATE, ATE, and OUS acid to ITE, ITE. Now check here. It is also ic acid. Now, when you remove A here, it becomes the ClO4. It is perchlorate, ATE. Now, when you remove this H, it becomes chlorate. Look. Okay, it is HClO2. It is chlorous acid, it becomes chlorite. It is hypochlorous acid, it becomes hypochlorite. Yes, boys. Any question?
Can you repeat the last one? Your voice was lagging. That's it.
Yes, no problem. And I am recording this lecture, so video will also be available. Okay. Now, you will change ICS to ATE and OUS to ITE. Okay. Now here it is perchloric acid. It becomes perchlorate. It is chloric acid. It becomes chlorate. It is chlorous acid. Yes.
If I take off the hydrogen, I said AAT.
Yes, very good. When you remove hydrogen from all these acids, it becomes ion like this: ClO4, ClO3 minus, ClO2 minus, ClO minus. So we are talking about this one now. What should be its name? Now I think too much here. Okay, now what should be its name? It is perchlorate, chlorate, chlorite, hypochlorite. Understand?
Yes.
Okay. You can revise it. If you will find any difficulty, you can let me know. Okay. Okay, friends. Our next. Okay, we have already discussed how to write a name. They have written here. This is the same scheme I told you. So if you have already understood, so no need for this slide or a previous slide here, because we have done all these things before. Okay. Now, okay, students, our last topic of this chapter, that is hydrates. What is hydra? What do you mean by hydrate? Hydra.
Water.
Excellent, water. Okay, students, sometimes we prepare some inorganic compounds in our chemistry lab, then some water molecules are attached with the crystal of that compound. For example, when we prepare copper sulfate, then 5 water molecules are attached within this copper sulfate crystals. Now these water molecules are known as water of crystallization. These are entrapped within the crystals. Okay. Now, whole molecule that contains this water of crystallization is known as hydrate. So this is a hydrate. Okay, some other LiCl, there are many examples in your book. So it is also hydrate. Now question is, how to write the name for these hydrates? Okay, there are some examples. For example, here BaCl2.2H2O. Now you will write the name as it is. We have already discussed. It is barium. Okay, chloride, barium chloride. Now, how many water molecules?
2. It's dichloride.
Very good. Dihydrate. So barium chloride dihydrate. Okay. Don't say it is a dye water. Okay. Be careful. Okay. Next. It is lithium chloride. How many water molecules?
Monohydrate. 1.
Excellent. Monohydrate. Very good. Okay. Next. What should be its name? Magnesium sulfate heptahydrate. Very good. 7 hepta. Excellent. Heptahydrate. Okay. Now SR is a strontium, boys. Strontium nitrate tetrahydrate. Any question? Okay. Now, what should be its name? CuSO4.5H2O. Any student? Okay, students. So now you see the impact. Okay, boys. Here. Listen, students. Here you see the impact of this water of crystallization. Now, when this water of crystallization is with copper sulfate, this hydrate, its color is blue, and when you remove this water of crystallization, it is white. Very good. Okay. Now, what should be its name?
Copper sulfate.
Okay. Copper sulfate pentahydrate. All students agree this one is correct now?
Yes.
Okay. All students will get 0. Wallah, ya Shabab. It is copper. It is transition element. So it is copper 2 sulfate. Understand? Copper 2 sulfate pentahydrate. This is correct. Clear this one?
Why you said 2, doctor?
Yes, why so?
Because it is a transition element. Copper is transition element. For transition element, we always write. Yes?
How did you know it's 2?
There's no 2.
Yeah.
Okay. Very good question. Boys, listen here. You can find charge here plus 2, suppose here SO4 minus 2. If you don't find charge here, it means this radical has cancelled its charge, is it? Is there any charge here? Did you find here in copper sulfate? No.
No.
You did not find charge here. If no charge, it means two things. Maybe one, maybe both have same charges.
Yes.
So if both have same charges, it means what is the charge on sulfate? Minus 2. What should be here? Plus 2. Understand?
Yes.
Clear this one, all students?
Doctor.
Boys,
is
listen,
there,
listen, again, I will repeat. That's very good question. Now listen. There are two things. Suppose I write Ca calcium sulfide, suppose CaS minus 2. Both are same, they will be cancelled. CaS. So if I ask you what is the charge on calcium, you will find from here. Okay, and what is the charge on sulfur? You will find it from here. If there is no charge here and here, it means both have same charges. Okay, so here in this case SO4, what is the charge on SO4? Minus 2. It means there must be a charge on this element copper plus 2. That's why both will cancel. The charge on copper, it is plus 2. Yes, any question? Any other question, boys? Any student still?
That's okay. But
It's okay? Okay. Okay, students, so this is our today's lecture. This is just for your information. These compounds are used in our common daily life.